Very nice. And also Dr.Kausar is assistant professor, Department of Government Research. So, we begin letters of skewness unknown from the topic of the previous topics, measures of central tendency and measures of dispersion. We have learned to find a single value that represents the entire mass of data and the extent of spread of values in the data from that single value. But we may come across frequency distribution which differ widely in their nature and have the same measure of central tendency and the measure of dispersion. In a frequency distribution, the spread of the values may be symmetrical around the center. If the values are not distributed symmetrically around the center, then such kind of distribution is said to be skew. So skewness means asymmetry or non-symmetry. It is nothing but the lack of symmetry. So skewness is nothing but the lack of symmetrical distribution or asymmetrical distribution from the central point is called as skewness. So in case of skewness, we are having three types of skewness. One is positive skew distribution, negative skewness, and no skewness. Let us will come across what we mean by positively skewness or positively skewed distribution. In case of positively skewed distribution, the value of the mean is the greatest and the mode is the least. Even the positively skewed distribution ಯಾವ ರೀತಿ ಇರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಯಾವಾಗಲೂ ಮಾಡೆಲ್ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇರುತ್ತೆ ಈ ರೀತಿಯಾದಂತಹ ಒಂದು ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ನಲ್ಲಿ the tail of the curve is extending towards the right side ಅಂತ ಯಾವಾಗಲೂ ನೋಡಿ ಈ ಒಂದು ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಎಂಟೈರ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಲ್ಲಿ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಆ ಒಂದು ಟೇಲ್ ಎಕ್ಸ್ಟೆಂಡ್ ಆಗ್ತಾ ಇದ್ರೆ ಸೊ ಅಂತ ಒಂದು ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅನ್ನು ನಾವು ಪಾಸಿಟಿವ್ಲಿ ಸ್ಕ್ಯೂನೆಸ್ ಅಥವಾ ಪಾಸಿಟಿವ್ಲಿ ಸ್ಕ್ಯೂ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ where the value of mean is more than the value of median. Again, the value of median is more than the mode. So we come up, we can see very clearly that the value highest average is mean, the lowest value is mode. So such kind of distribution is called as positively skewed distribution. The next type of distribution that is called a negatively skewed distribution. In case of negatively skewed distribution, it is quite opposite to the positive, where the model value is having the maximum value and the mean value is the lowest. In this case of distribution, we can able to see the left side, the tail of the curve is extending towards the left side, where mean is less than median, where the median is less than mode. So this is the way how the negatively skewed distribution can be seen. And the next type of distribution that is called as no skewness, where there will be no skewness, where we can able to see all the averages are equal to each other, where mean is equals to median, median value is also equals to model value, where the entire distribution or in the entire distribution all the averages values are same. Such kind of thing, both the tails are having the same measurements. Such kind of distribution is called as no skewness. In case of skewness also, how we used to calculate in dispersion in the same manner, we used to calculate both absolute measure as well as the relative measure. In case of absolute measure, we are going to calculate with the help of actual terms of the units. So these are all the formulas where we can able to use for the calculation of absolute measure of dispersion based on averages. So skewness can be calculated by mean minus median. This is also one of the formula. Again, if the information is being given about only mean and mode, then we can able to find out the difference between mean and mode. It can also be called as skewness. See in the problem, if the averages has been given only median and mode, then the difference between the median and mode is also called as, we can able to calculate skewness. In case of quartiles also we can able to calculate. So the skewness form means the upper quartile plus lower quartile minus 2 median. With the help of quartiles also it is possible to calculate the value of skewness in case of absolute measure. And the next type of measure that is called as a relative measure, where we used to call it as a coefficient values, where we are going to express the values in terms of percentages or in terms of ratios, which is possible for comparison. According to your syllabus, you are going to have only one type of coefficient of skewness, that is nothing but Carl-Pearson's coefficient of skewness, that is called as SKP. While calculating the Carl-Pearson coefficient of skewness, again we should see when mode is exact. We can able to see where the maximum frequencies or the number of variables, the highest value is only one. So at that time, the highest variable or the highest frequency will be called it as corresponding to the value of the variable, we will call it as the model value. Well defined means where the exact value of model value is there. So at that time also we can able to calculate Carl-Pearson coefficient of skewness, that is called as SKP shortly. The formula is mean minus mode divided by standard deviation. If mode is redefined means when two variables are having the same frequency or the two frequency values are same. Corresponding to that, the two variables we are finding very difficult to say whether the value of mode is there. So at that time we can able to say that the model, the Carl-Pearson coefficient of skewness will be 3 into mean minus median divided by standard deviation. These are the two formulas where we are using for the calculation of skewness, that is Carl-Pearson coefficient of skewness, based on the information what they have been given. If the mode is exact, you can able to use this formula mean minus mode divided by standard deviation. If mode is not exactly ill-defined, at that time we can able to use the formula, that is SKP equals 3 into mean minus median divided by standard deviation. Let us in this thing, we can able to see how the 2 marks questions will be given for skewness, that is HKT. See, the first question is the mean and the mode of the weekly wages of group of workers are rupees 45 and 36. So here the value of mean is 45 and the value of mode is 36. And also he has given in the question that is standard deviation, the value is 18. Now we should find out the coefficient of skewness. Here he has given to calculate only the relative measure, that is coefficient of skewness. So very clearly he has mentioned the value of mode. So we can go for exact where the well-defined formula, that is SKP equals mean minus mode divided by standard deviation. We have to substitute the same thing in the formula. 45 minus 36 by 18 is nothing but 9 by 18. The value of Carl-Pearson coefficient of skewness is 0.5. See the second question again, they have given the value of mean equals 23, median equals 25, standard deviation value is 10. So by seeing these values where the model value is not there, so they have given the median value. So now we should go for the second formula. We can able to think that the value of mode is redefined. So we can use the based on this observation, based on the information what they have given, we can go for that using the formula. That is SKP equals 3 into mean minus median divided by standard deviation. This is the formula where we will use for when the model value is not given or well defined. So we have to substitute 3 into the mean value is 23 minus median value is 25 divided by 10. So 3 into 23 minus 25 is minus 2 divided by 10. The value will get is my negative value. That is minus 6 divided by 10 is minus 0.6. See the third question we have given here. The mean of the distribution is 50, standard deviation is 15, and coefficient of skewness is minus 1. So with this information, now we need to calculate median value by using SKP formula. So let us will substitute the values to calculate the median. SKP equals 3 into mean minus median by standard deviation. Now SKP value is minus 1 equals 3 into substitute the value of mean, that is 50, minus median we have to calculate. We write down the m as it is divided by standard deviation value is 15 equals. Now we are going to do cross multiplication. We are shifting this 15 to the left side. Minus 1 into 15 will become minus 15. It will become is equals to 50 into 3 is 150 plus into minus is minus 3 into m is 3m. This is the equation what we got after doing the cross multiplication. We need to calculate the value of median. So this 3 means can be shifted to the left side. It will become plus 3 means. Then retain this 150 and shift this minus 15 to the right side. So it will become plus. So 3 million equals 165. So the value of million equals 165 divided by 3. It is number 55. So this is how, based on the information, we are going to calculate the value of mean, median, or mode. And the next information here, there is one question they have given, that is the fourth question. The SKP coefficient of skewness of distribution, that is the coefficient of value given, that is 0.32, and standard deviation is 6.5, and the mean value is 29.6. Now they are going to calculate the value of mode. Substitute the values in the formula, that is 0.32 is equals to mean value is 29.6 minus mode, we don't know what that has to be calculated, divided by, in place of standard deviation, we should substitute 6.5. Now we can go for cross multiplication. We can shift this 6.5 to the left side by multiplying it with 0.32. So 0.32 into 6.5, that will become the numerator value retain as it is after shifting this 6.5. Then 29.6 minus 4. Now we'll have to multiply the left hand side where 0.32 into 6.5, the value will be 3.08 equals 29.6 minus 4. We have to calculate the value of mode. This minus z should be shifted to the left side so that the numbers can be shifted to the right side to calculate the value of mode. So z equals 29.6. This 2.08, which is having a plus value, when you are going to shift to the left side, it becomes minus 2.08. Therefore, the value of mode is 27.2. So this is how we are going to calculate in the, if the question is being given for the 2 marks. Let us will see here that one more question they have given. It is question number 5 for not only for calculating this SKP but also for the CV value. Let us will see how to substitute the values and with the help of CV what to calculate. In a moderate skewed distribution, the mean is 15, median equals 14, and the CV is 30%. Find SKP. We have to find out the value of SKP because CV value is also given. Let us then substitute the value, that is what 3 into mean value is given, that is 15, median value is given, that is 14. But in the question they have not given the value of standard deviation, but they have given the value of variance, that is coefficient of variation is 30%. But using this CV value, we need to calculate the value of standard deviation. Let us then check how to calculate the standard deviation by using CV. So we know that CV equals the coefficient of variation is equals to standard deviation divided by mean into 100. Let me substitute the CV value, that is 30 equals to standard deviation by as it is divided by mean value 15 into 100. Now we can able to shift this 15 to the left side, multiply with 30. 30 into 15 is equals to SB into 100. Then 15 into 30 will become 450. Then to calculate ST, the 100 is in the denominator, we can shift to the left side, it becomes divided by 100. Therefore, the value of standard deviation is 4.5. With the help of this CD, we can able to calculate by using the CD formula, we can able to calculate the value of standard deviation, that is 4.5. For what means to calculate SKP. Then we can substitute this 4.5 in the denominator. Then SKP equals 3 into 15 minus 14 is 1 divided by 4.5. Therefore, SKP equals 3 into 1 is 3 divided by 4.5. Therefore, the coefficient of qualification coefficient of skewness is 0.6. So these are all the 2 marks questions how to calculate for the calculation of skew. Let us see that there is a 6 marks question how to calculate. So this is the discrete series for the calculation of SKP. Here they are given, that is the size, the variables 12, 14, 16, 18, 20, 22, and frequency value also 1, 4, 6, 10, 7, 2. Now we know that for the calculation of SKP, we can able to see by seeing this question itself, we can able to decide the model value, highest frequency corresponding to that is 80. So therefore, the model value can be said as 80 because here it is exact. We can able to see it very clearly by the instruction method that is highest frequency is then corresponding to that 18 is the model value. So by using the Corey-Pearson coefficient of skewness, that is the first where the mode is well defined. So it is nothing but the formula That's what we are going to use. Escape equals standard deviation. So mean minus mode divided by standard deviation. So these are the formulas. So we need to calculate mean value, mode value, standard deviation value. So with this discrete series, how to calculate the standard deviation as it is by using the information we need to calculate. One will be the x values, what I have done. Another one will be the f values, has to be written as it is. Now we need to calculate the value of mean. So we are using the formula that is a shortcut method. So shortcut method, the formula for the calculation of mean is that is mean equals a plus sigma fd by n. To substitute these values, we need to calculate the values in the column. So now we'll have to do the total of n. How we used to do in the averages in the same manner, we'll have to apply here n equals 30. Now we'll have to do the deviations with the help of assumed mean. So here we have taken 80. So where there is 18, we are using x minus 8, that is 18 is assumed mean. So 12 minus 18 is minus 6, 14 minus 18 is minus 4, 16 minus 18 is minus 3, 18 minus 18 is 2, 0, 20 minus 18 is 2, 22 minus 18 is 4. But for the formula, we require to substitute FD. So FD means we have to multiply with all values in the F column. 1 into minus 6 is minus 6, 4 into minus 4 is 16, 6 2 are 12, that is minus 10 into 0, 0, 7 into 8, 13, 2 into 4 is 8. Total all the FD values for the substituting the values in the mean. That is sigma FD is 12. Now we can able to calculate very easily the value of mean. So mean equals A plus sigma FD by n. The assumption we have done A is 18 plus we got the negative value of this because the highest values are minus. So FD is negative. We have substituted minus 12 by 30. The value of mean is 17.6. So we calculated mean. We know what is the model value, the instruction. So here 10 is the highest frequency corresponding to that the value of mean is 18. Now what we require to calculate SKP, that is standard deviation. For standard deviation, we can go for shortcut method. So the standard deviation equals root of sigma fd square by n minus of sigma fd by n whole square. Now we should calculate, already we have calculated d column in the table. So now we will require to calculate d square and fd square for the total. So d column, d square column is square minus 6 into minus 6, 36, minus 4 into minus 4, 16, minus 2 into minus 2 is 4, 0 into 0 is 0, 2 into 4 is 2 into 2 is 4, 4 into 4 is 16. Then we'll have to multiply all these squares with the x column. The total of sigma x square is 184. Let us will substitute the values in the formula. That is standard deviation equals root of sigma fd square by n, that is 184 by 30 minus of sigma fd value is 12. Okay, minus 12 divided by 30 whole square. Then we are getting the value of standard deviation is 2.4429. So this is what we require for the calculation to substitute in the SKP. Now we are substituting the in the SKP formula all the averages, that the average both mean and mode as well as standard deviation. So the value of mean is 17.6 minus model value is 80 divided by standard deviation is 2.4429. So we got the coefficient of SKP, that is mean is value is negative, that is 0. Minus is 0.16. So this is how we are going to calculate with the help of discrete series. Let us then see one more question, how to calculate in the continuous series. In the continuous series, we know one will be the class interval, another one will be the number of students. So again, how we used to calculate the averages in the same manner we can calculate. Now, in this question, so again we can able to see very clearly here, that is as it is a continuous series, the highest total frequency is 35, corresponding to that the value of the model value is lying in the class interval of 40 to 50, but we don't know what is the exact value. So we are going to use the formula, that is del d equals L plus f1 minus f0 divided by 2 f1 minus f0 minus f2. That is the formula where we are using for the calculation of mode. So in the same manner, here we have to calculate for mean and what standard deviation. In this also, first column we are marking the class intervals, what they have given in the question. In the second column we have to mark the frequencies. Then we know for the calculation of mean, first we require to calculate the midpoints value also we need to calculate. Then we have done here according to the step deviation method d dash value, that is nothing but m minus a divided by c. So d dash value also. Then we have calculated d dash square. Then multiply with the f d dash and f d dash square for substituting both in mean and what standard deviation value. Now escaping, we know that as it is exact, we can able to see by instruction in which class interval is located. We can use a well-defined formula mean minus mode divided by standard deviation. Here we are using the formula for the mean equals a plus sigma f b dash by n into c. So mean equals the value of a here we have taken, that is 35 as the assumed mean. So substitute the value 35 plus sigma f d dash. The value is 191. We have substituted 191 divided by n value is 150. Then the value of d is 47.7. Similarly, we are using the what model formula, because in the class intervals we can't able to find out what is the exact value. So we are using the formula, that is L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 in this. Now L value is 40 plus 35 minus 21 divided by 2 into 35 minus. See, we can see in this question the highest frequency is 35 is F1, preceding to that number. Preceding to the number is F0, succeeding to the number is F2. Now we have substituted all the values of the formula. Here it is. So that is 2 into 35 minus 21 minus 30 into 10. The value of mole is 47.368. Now we are using the standard deviation formula as we have used the d dash. So we can apply the formula for step deviation. So root of sigma f d dash square by n minus sigma f d dash by n whole square into c. So d dash square is 729 divided by 150 minus f d dash is 191 divided by n value is 150 whole square into 10. So we got the, after substituting and calculating the values, the standard deviation value is 17.997. Now we should, after calculating all the average, that is the mean and the mode, then standard deviation, now we should substitute the value for the calculation of SKP. So that is nothing but mean minus mode divided by standard deviation. 47.733 minus 47.368 divided by 17.997 is equal to 0.020 is the SKP the answer. So let us, we can see one more question what they have given here, the all marks above and number of students. So marks above means the frequency values will not be simple, it will be the accumulated frequencies. How we used to calculate for the mode and what for the average in the same manner we should do. So marks above means we can able to write it has started from 0, we should start from 0. So above is nothing but all will be the lower limits. So 0 to 10, 10 to 20, 20 to 30, up to 70 to 80, we'll have to write down all the class intervals. Now here up to 70 to 80, then we should go for all the cumulative frequencies has to be converted into simple frequencies. How we used to do in the previous classes, in the same manner we have converted. Then we found out the highest frequency value is 40. Corresponding to that, the class interval is lying is 50 to 60. That will be considered as the model value. The preceding number will be called as F0. The succeeding number will be the 16. Now we have to calculate for the calculation of that. Here also we have calculated according to the step deviation method. First we need to calculate midpoints, then d dash square, then multiply for the substituting the values in the formula for the standard deviation f d dash and f d dash square. The same thing has to be substituted and calculated according to the continuous also. So this is how we are going to calculate the values of skewness. That is SKB. There is only one clarification question of skewness will be calculated. As it is, we know that in all the averages, we are well know that how to calculate all the averages by using that formula, whether it is well defined or well defined, we have to apply the